Max Planck was a German physicist and is best known as the originator of the quantum theory of energy, for which he was awarded the Nobel Prize in 1918. Planck's work in thermodynamics led to the formulation of his quantum theory, to explain the colors of hot glowing packets rather than in a continuous unbroken wave. Planck called the packets of energy quanta, and he was able to determine that the energy of each quantum is equal to the frequency of the radiation multiplied by a universal constant that he derived. Albert Einstein published his special theory of relativity, which led to his designation as the father of modern physics. Einstein also in 1905 proposed that light energy can be absorbed or emitted only in discrete packets called quanta. He also explained the equivalency of mass and energy expressed by the famous equation E equals mc squared. In 1913, Bohr proposed his quantized shell model of the atom to explain how electrons can have stable orbits around the nucleus. The motion of the electrons in the Rutherford model was unstable because, according to the classical mechanics and electromagnetic theory, any charged particle moving on a curved pathway emits electromagnetic radiation. Bohr modified the Rutherford model by requiring that the electrons move in orbits of fixed size and energy. The energy of an electron depends on the size of the orbit and is lower for small orbits. Radiation can occur only when the electron jumps from one orbit to another. The atom will be stable in the state with the smallest orbit. Schrödinger, an Australian physicist, expanded on Bohr's model. He used a mathematical equation to describe the likelihood of finding an electron in a certain position. Unlike the Bohr model, the quantum mechanical model does not define the exact path of an electron, but predicts the odds of the location of the electron. Werner Heisenberg discovered the uncertainty principle. He said this means that the electrons do not travel in their orbit. So all electrons that contain photons will then change momentum and physics. Werner's contribution to the atomic theory was that he calculated the behavior of the electrons and subatomic particles that also make up an atom. Instead of focusing mainly on scientific terms, this idea brought mathematics more into understanding.